Hey, in this video I'm going to show you a simple system that will allow your game mechanics to be quite flexible and easy to adjust. You could call it the observer pattern, but let's just say it's a rather lightweight implementation of it. And that is something I also wanted to talk about in this video. So recently I've been reviewing a bunch of projects where people implemented design patterns kind of blindly, and the result is way more complexity than there should be. Don't get me wrong, I love design patterns, and when you're learning them, just implementing them might be a good idea, just play around with it. But ultimately, you should really understand what each part of this pattern accomplishes. So keep in mind, a design pattern is really just a common solution to a common problem, but your project and therefore your problems are going to be unique. And if you really understand these design patterns, then you can start like stripping them apart, use this part, use that part, combine them, and just be way more flexible. So in that sense, I will explain why I think this trimmed down like light observer pattern version is a good solution for my current project. And in the end, I will talk about how I would adjust it based on certain advantages that I might want to implement from the observer pattern. I'll start with a quick overview of the system. I'm going to show you the main script real quick. But before we go into detail, I'm going to show it to you in action by launching this rocket. This is a virtual reality game I've been working on. And this system has helped me a lot because it kept everything nice and flexible and things don't break when I make changes. And I've made a lot of changes and I expect to make a lot more changes while I'm developing this game. Then when we're back down on Earth, we are going to take a look at the scripts in detail. I'm really going to step through the code, like give you some examples how this actually works line by line. At the core of this system is a scriptable object called mechanic. And then I make instances of it and give every instance a very specific mechanic that it represents. So keep in mind, instances of scriptable objects, they are created in your files. They are tied to assets. They're not created at runtime in memory. If you need further explanation, I made a whole video about that. But for now, let's just say every instance is a very specific game mechanic. And all that really is in the scriptable object is a bunch of events and a bunch of methods to trigger these events. Well, all of this is public. So any class that has a reference to one of these instances can say, I want to subscribe a method when on trigger happens, on toggle, on float change. So these three, they are the main things that control or rather inform that this mechanic actually happened. And then I have two more. They don't really trigger this mechanic, but they're quite helpful. So one is on show Q to target value. And that is basically just a script saying, I would really like that event to happen. I don't care who's gonna make it happen, and I might not even care when it happens, but please make it happen. If anything is responsible for giving a cue to the player, and we're gonna see that in action 2, then please show that. And you have the target value. So for example, the thrust slider, like the engine says, I would really like the thrust slider to be to 1 so we can finally lift off. And then there will be some visuals that show that to the player. And here on log change, this is also to make sure it says like, okay, now would be a bad time for this event to happen. And keep in mind, I'm not saving any of these values in the scriptable objects. So this is just a little intermediary thing. So you have classes that can subscribe and you have classes that can trigger it. Right, and the trigger is super simple. So if I want to change the float, I just call this public change float, pass in a new float value. And then I say, if anything is listening to it, okay, let's invoke this onFloat changed event. And of course, also pass the value on. And here I have some debug. I'm going to get into that later. So for now, this is pretty much it. We can have class A that says, I want to be informed whenever this event action on trigger happens. And when that happens, I want to call a method that it has the same parameters. In this case, it has none. And then we could have class B that says, okay, I'm gonna trigger this event at certain times. And the nice thing is class A and class B don't need to know about each other. I can remove class B, I can remove class A, I can add class C that also would like to be informed when this thing happens, class D, and so on. And I can, and I do even do that at one time. So this is really nice and flexible. So I have two main things that are kind of like communicating through these events. One is this mission control that's responsible for, keep everything in check here, make sure, okay, first we close the landing legs when they are closed, then it's time to toggle the engine and so on. So this is gonna take control of the entire mission. Well, mission control, I guess that name is correct then. And the other thing that is responsible for triggering most of these events is this control terminal here, right? A lot of these things, they also have a reference to one of these instances, and so they can say, hey, one of these things happened. So let's just take a look at this flight in action. All right, so I'm now in virtual reality, and I try my best. I always have to mind, I'm basically only like recording this thing, but I'm seeing way more, much bigger field of view than the Unity shows me. Anyhow, the mission control now just said, okay, first things first, we need to close those landing legs, right? They should not be open during liftoff. And so it just said like, I want whoever's listening to this thing here, just please show the queue. And there just happens to be this landing legs toggle that is listening to it. And that also is listening to the queue, right? So it says, okay, if something wants those landing legs to be closed, I should probably blink this light. And of course, if the other way around, it says if something wants those legs to be open, I'm going to blink this red light. And so when I flip this toggle now also triggered the close landing legs command. And there just happens to be an animator listening to it. There also happens to be an elevator listening to it. So we are starting to go up this rocket. And of course, the mission control that also listened to the close landing legs command and said, all right, well, when that is done, I think now it's time to start the engine. And this is what this box here is for. And again, the mission control has no idea who's going to show the queue. It just says, please, if something is responsible, I just want to trigger this event. And of course, this toggle engine box was listening. On a side note, and I think that shows the flexibility, this toggle here was directly connected to the landing legs command. These toggles, however, and I'm using some inheritance, but let's not get too distracted, they are not directly listening to it because it's actually this box that has a script on it. That one has the reference to the toggle engine command, and then it just checks when these things get toggled, and it says, first of all, if something wants the engine to be turned on and off, it is listening to that event, and that just got triggered by the mission control. So it says, okay, I'm going to show these blinking lights. And now when I flip these 1, 2, 3, and when this third one is flipped, now the engine is turned on. Because if you watch a lot of action and sci-fi movies, you always need 3 toggles to do like things, and it's fun to do more than just one. Especially if it's fast, like flip, flip, flip. But I did it slow just to show it to you. You might also notice down here, there is now some fire and smoke. And those are particle systems that had a script on it. And they were also listening to it. They said, okay, well, when the engine gets turned on, let's show a little bit of smoke. Let's show a little bit of fire. Like there are 2 fire systems, 2 smoke systems. They just listen to it. And then, of course, the mission control also had a listener and said, well, when the engine is turned on, time for the next step. And that is the thrust. And this happens to be the thrust slider. Once again, it says, I would like to show the queue. I would like this value to be 1. And then the slider happens to be listening to it and says, well, the value is 0 right now, but hey, I can make this 1. And maybe I should show these blinking lights here, because that's how you get to a value of 1. And of course, the smoke and the fire, all of this is now also listening to this thrust. And this is sending out a float event. So instead of just a toggle, every time I move this slider, so basically every update loop, it's going to send out that this float value has changed, right? So you can hopefully see the fire down there. It's actually directly connected to it. It says, all right, every time this changes, I might want to show more fire or smoke. And by the way, we are not lifting off because the rocket engine it's listening to it, but it says, okay, I only care about if this thing is all the way to the max, because you don't want to lift off with like a little bit. It's got to be like all the way to the top. So it listens and says, is this value finally 1? And now we can do that. So if I go all the way here, now it's 1. I just remembered I have the rocket speed way too high. That was for testing. Okay, so anyhow, it was 1 and it says, all right, time for liftoff. And off we go. And I hope you understand the system, right? So everything has reference to these commands. Then we have all these other things listening to it. And that means we can fly to the pizza. And also I'm using this lock. So for example, when the engine got turned on, it says like, okay, lock it. Don't do that anymore. For the legs, it's actually different because the legs only locked it. The animator locked it. And it says, no, once the animator is done, it passes that on and says, you know what? Let's just unlock it. I just did that for now. That's the idea is I can change that very dynamically. So if I flip this now, the leg's gonna open. And right now it's locked, so I can change this. But as soon as this is done, let's go up a bit. And yeah, we're going into space pretty quickly. Again, this was just for testing it. It's supposed to take a little bit longer to get into space. So now we're done, and the animator says, okay, you know what? Whoever's responsible for closing and opening the legs, you can do it again. And so this toggle is now usable again. So I can close these legs. I think it would be fun if in the game this is actually like this could happen accidentally, like you just like touch it and then you open them and like, oh no, and you just they whip off or something. Okay, let's take a look at what actually happened in the code when I played this game. So we started with these leg toggle here, right? So this one has a script called toggle legs. It inherits from a base class toggle, and the toggle is really just responsible for, okay, did this handle flip? Did it flip up or down? And then we say, okay, we turned it on and off. Also has this show queue. I'm going to show you in a second. So, but first of all, this one has a serialized field for mechanic. So here in the inspector, I can say, okay, which mechanic is this toggle responsible for? And I just realized I shouldn't have called it toggle legs, because if I can go in here, I just click the circle. Now it's going to only offer all the instances of mechanic that I have. I could say deploy fairing, and now it's responsible for deploy fairing. So I guess better name would be toggle mechanic or something. But yeah, I hope that shows you a little bit how flexible the system is, because like that's it. Now I don't have to change anything anymore. If I flip this now in the game, then the fairing is gonna lift off. And it's of course also going to take off. It's only going to show this queue when something wants the fairing to take off. Let's keep it at closed landing legs. Right, so here in on enable, we listen to when something wants this to be locked. And in this case, as I mentioned, that's the animator. And all I do here is when that happens, I say toggle lock. That's sitting in the base class. It just says the rigid body, make it kinematic, so we can't move it with the physics head. Then we also have on show queue to target value. We also want to know about that. And there is one called show queue. That's in the base class, right? We're here in toggle. Show queue. And it just makes the lights blink. That's all. Like based on if you want 0 or 1, it says, okay, the red light should blink or the green light should blink. And that's it. And here in on handle flip, we're overriding this. And when this happens, then we actually trigger this command, right? So reference to this command, say command, toggle, and turned on or off. And as I mentioned before, here, this is just the mechanic in here. And we toggle this. And when we call this toggle, what happens is we invoke the on toggle event. Okay, let's take a look at the other side, and that's this mission control, right? It's basically just a list of these mission step classes. They are not modern behaviors, so I can just put them in a list. And thanks to Odin Inspector, and like that alone is absolutely worth the price. You can make this, you can make a list called mission step, and now when you want to add an instance, it says, do you want to add maybe the base class, or do you want to add maybe any class that inherits from it, such as ms wait for toggle or something? And that's just super awesome, because now I can fill it with instances of child classes and have a lot of control. So the first one that I use here is ms wait for toggle. So mission step wait for toggle inherits from mission step. And here I can assign a control, right? So I choose close landing legs. For some reason, I might want to toggle the engine first. I could just do that. And now, if I were to play the game, it would actually go in here because this one is listening to the engine. And then it would say, okay, target value means we want to turn it on. These other three things, they're just related to the actual mission step, right? And it is super simple. Let's take a look here. Mission step. I have most of them in one class. Yeah, wait for toggle. So all I have is a field called target value, and of course the serialized field for the mechanic. Called it control, should probably call it mechanic. And when we start this step, that's what this mission control says. It always says, okay, let's start this step. When it's done, we'll end it, and then I'm going to go through this list into the next step. And so what we say here is control show queue. So we're going to call this method that, as I just showed you, the toggle legs is already listening to. And it just says, well, if the target value is positive, send out 1, otherwise send out 0. And then it also adds a listener itself, right? It says, this is where I want to go, but also if this happened, I would like to react to it. And so it says, when this toggle event now gets triggered, I'm going to check, well, is it the target value that I actually hoping for that's going to happen? And if so, I'm going to finish the step. And then the mission control just takes that and goes to the next step. Also important, I'm unsubscribing here, right? Because I don't want to keep listening once that step is done. So we go finish step. And yeah, that is pretty much it. And then we can do all these things, right? So here I have ms wait for toggle. So I wait for the, oops, that's the engine now. So we start with the close the landing next, toggle the engine, and almost the same here, change float. And we can take a quick look here. Change float. So once again, we have a serialized field to a mechanic. We have a value to reach. Threshold, I just make sure that it's, doesn't have to be exactly 1, but that's really just because of this being virtual reality, and maybe the player only slides it to like 0.99. And then I still want this to happen, so I have a little bit of a threshold here. But it's exactly the same. I have this control and I say, okay, show queue, where do I want to go? So if anything is listening to it, then please show that we want to change this value. And of course, we also add the listener. Well, if this then happens, I would like to react to it. And here we have this finished step. And as I mentioned, I can now hook up a lot of other things to it, right? So for example, the mission control could also trigger these methods. I think I might do that at some point. It says like, well, you should deploy the pairing now. And if the player doesn't do it, the mission control says, I'm going to do it for you, but maybe you get less XP or something. So any class can trigger these mechanics. And I can also add all these effects, right? The mission control shouldn't be responsible for the fire effects. The fire effect should be responsible for that. Let's actually see. So here I have the thruster. It should be pipe smoke, fire. Okay, this is the fire that's listening to the thrust. Right, so I have a very simple script called fire main thrust. And as you can see, it is listening to two mechanics, toggle engine and the thrust command. Let's take a quick look at that. I think this is a simple example. Particle controller, that's just where I push the mechanics to actually change the particle system. The important thing here is we have these two reference fields, right? Toggle engine command and thrust command. And yeah, I kept changing these. They were called controls, then they were called commands, and now they're called mechanic. So eventually I have to change all these fields. So on enable, we want to listen to the engine command. That's it for now, because we don't want to change the particle system when the engine isn't even turned on. So when we say, okay, when something flips this toggle, I want to listen to these. I want to call the toggle fire method. And if it gets turned on, that's when I start listening to the actual thrust command, and I set the start speed of these particles. That's basically all I do for the particle system, make it go like, to have like this little flame, right? If I increase the speed, then it's gonna look like what you just saw in the game. When I turn the engine off, then I don't need to listen anymore to like the set start speed min max. In where you could keep that on, but then it's unnecessary, right? So, oh, now let's make sure only unsubscribe, of course, if we're listening to this thrust. This is why I have this spool. You get an error message if you unsubscribe a method. You're trying to unsubscribe a method that was never subscribed. So this will also do in on disable. Make sure if we actually were subscribed, then we can unsubscribe. And I just realized I'm not unsubscribing to this one. That is not good. Yeah, I forgot that. So here I should do the same, right? On enable, I don't need, and on disable, I should unsubscribe. I hope you can see the advantages of this system. It's really flexible. And so I think it's really good for this stage of the project where I'm just trying to play around with a lot of things, because basically everything you see in this game has been changed like 5 to 10 times. And thanks to that system, I didn't have to go in and then just rewrite code all the time or have things falling apart. I can just easily say, you know what, let me try like an extra smoke effect here on the launch pad. Let me remove that. Let's do that later. And you know, it's really flexible. And I think for this stage, it's really good. Also have this hacker script here that's for testing, and that's just another way to trigger all these events. And especially in virtual reality, it's pretty inefficient having to always put on your headset and then just like physically do that with the hands. So I just have reference to these mechanics, and then I just made some sliders that says, okay, if this changes here in the editor, I can change that too. So I can say turn on engines, and I say, okay, invoke, right, turn on the engines by, where is it? Toggle engine. So this one got triggered. And here I can use the thrust slider. So this is really useful for testing. And it also skips this whole mission control thing. But I can just directly hack into this and change whatever I want. And furthermore, they're also all in one place. So sometimes I don't have something in the hacker in here, but I put them all in one folder. So I could just say deploy fairing. And I showed you that like they all have these button attribute that's Odin Inspector. You can also use the context menu attribute that allows you to then like right click a script and then you see the method here. But really, if you use Unity more than just once in a while, I would highly recommend just get Odin Inspector. So I can go in here, deploy fairing, and let's see. Oh, I can just click trigger. Oh yeah, and it's lifting off, right? So really useful for testing. Now that I showed you all the good sides, let me also show you the bad sides. And I think the most obvious downfall of the system is confusion. So for the thrust, right, I use a value between 0 and 1. So the slider just triggers it and it sends it calls this change float method. But what if I add something that wants to react to the thrust and somehow I get confused and think thrust, that's a Boolean, right? So I just add a listener to this on toggle command. And when the thrust changes, it calls this change float method, invokes this on float change event, and whatever wanted to listen to this on toggle is just left in the dark. And there is no error message saying like, hey, I think you messed up something here. Bunch of solutions. So first of all, not to push my own system, I'm really always trying to say objective, the good sides and the bad sides. But I had absolutely no issues so far with this because it's a small project. And also I'm the only one working on it. So if you have like 5 people occasionally work on this thing, then of course there's a much higher chance for confusion. So I have a bunch of debug methods. So one, I just wrote this as an example, right? So here I say if I invoke it, and I could toggle this debug mode on. That would, for example, inform me that, first of all, it says, hey, something just tried to change this toggle. And if on toggle equals null, that means there are no listeners. Then I would get this debug no listener method. And it would just basically print to the console, hey, you trying to trigger this command and no one is listening, so there might be some miscommunication. Also have this button here to show me the subscribers. So you can actually, that's more a C# thing. You can go in here and you say get on trigger, right? That's the event. And you can call this get invocation list method. And then just for each one, I'm going to print out, first of all, this is the target and the method name. And so this would then just print me out the listeners. So at least like during the game, I say, hey, something's wrong. I think something is, shouldn't this engine be subscribed to this float? I can then just really quickly click this button and I see, oh, nope, it's not subscribed. And then of course, maybe I could go in here, do this debugging. Could be a solution, and that is using generics. So if this were not a scriptable object, this would come to mind, right? And then you just have one event here, use generics. Visual Studio doesn't know that scriptable objects are special, so it just says, oh, you want an instance of the mechanic? Okay, but so which one? Maybe this should deal with a float, and maybe this should deal with a bool. Visual Studio is totally happy now, but Unity is not, for a very good reason. For one, I could assign the same instance in the editor for this field, right? I could drag the thrust command in this field, and then I'd also drag it in here. And how the hell am I gonna say it's a float, and then I'm gonna say it's a boolean? So Unity, for good reason, is gonna say, nope, something is really messed up here. Not gonna happen. It's not even gonna go into play mode. What you can do is a concrete implementation. And that means you can have a base class of the scriptable objects where you use these generic, and then you inherit, and in this inherited script, you pass this on. I think I have this somewhere here. Oh yeah. Okay, so this would be the generic base class scriptable object, and probably make it abstract and, well, not create it. I guess you can make it abstract in the editor by just, more or less, by just not giving it an asset menu. Here you make all your methods, events, and always use this T, the generic parameter. And let's see, then you go in here. Now you can make a concrete implementation. You inherit from this one, and you pass in, okay, this is a float. Now you have a create asset menu, and this is going to allow you to do this. And then you could go in here and say create generic command float, right? And so now this is a float command, so you do, this would be the thrust. The reason I don't do that is because if I change my mind, then has happened a lot. Basically every mechanic I have changed from like float to integer to bool to nothing, then no, it's a toggle again, and so on. And that means if I use this method, then every reference that I have, where do we have a reference? Launchpad smoke has, I think, yeah, thrust command. So maybe I changed the thrust for some reason to an integer. I don't want this to be float. But that means now I have to go in here and actually delete that thrust instance and make a new one. But this time I make it an instance of these generic command float or generic command integer, the new one. And that means I just lost all the references, and now I have to go in here and assign all these references again. So it would be the safer method, but it would also be more work right now. And I figured as long as there's no confusion, I still have these debug, and I haven't even gotten to this one. I haven't even really needed to use these. Then I think the flexibility is worth losing a bit of safety. So in the beginning, I mentioned the observer pattern, and I think I was going to put this in the video title, so I should probably talk about it. In the classic observer pattern, you have the subject, that is a class that holds all the reference to the observers, aka the things that want to be notified when something happens. And that is pretty much this, right? This intermediary class that some classes can say, hey, I want this event to be happened. I don't care who's listening. And then something has to have a reference to this thing. It says, okay, I'm going to take care of that. I know who wants to listen. And so class A and class B, right? Class A triggers it, class B listens to it. They don't have to know about each other because the intermediary class, the subject in the observer pattern, takes care of that. So that is pretty much what this mechanic thing does. Why do I call it light? Because in the more classic observer pattern, you would use an interface, kind of like this. You have public interface I observer and then a method called like notify. So for example, if the fire wants to be observing the toggle engine command, it wouldn't just say like, yeah, I'm gonna listen to it. Like you don't have to worry too much about it, right? You would then probably do something like this. I observer, you implement this interface. I'm gonna complain because we don't. So implement it. Set on notify. And here we then just say like, do this thing and thrust changes. And now instead of just doing this like on toggle and then like subscribing like this, we would probably use, we would have a list like, and we can keep this private. So private list, not this list, I observer and then like servers. Could not be found. What the hell did I delete? Oh, I deleted that. Yeah, so it has this list, and then instead of just subscribing directly, you would have like a method, something like this: public void add observer. It takes the I observer as a parameter, and then it says observers.add. Okay, always suggest that. Also keep in mind, you have to make a new list, right? If it's private, this would give an error because it's null, but that's not the point. And now you have these observers in a list. And then, of course, instead of just triggering this command, you would go through that list, and for every observers, you call this notify method. And then, as I showed before, then the fire does its thing. And that is totally fine. But of course, you should ask yourself, why? Why do you need an interface with a specific method? One thing I could think of is maybe you have like something like this, like a priority. And then instead of just, oh, it doesn't interface. Let's complain doesn't implement it, implement interface, priority, and you could get like an integer. And this way you could then have much more control over what gets triggered first, right? This would be one reason, because then when you go through the observers, when this event happens, like the trigger event here, you say, okay, let's go through this list, but maybe let's sort the list first on the priority, and whoever has the highest priority gets informed first. So depending on your game, that could be a reason. Another reason is you don't just want to say on notify, maybe you want to do 3 different things when this event happens. And then you say like, prepare to, like, I don't know, like void brace for notify. And then you say like, clean up after notify, something like that. And now when you call these, when this event happens, and you say, okay, first of all, let's tell all the observers to prepare for this thing. Then we're going to call on notify in the observers, right? Yeah, that could be a reason. But as I said, I think you should really think about, do you have a reason for this interface? And as awesome as interfaces are, I hope you can kind of see, like this example shows you, there are very nice advantages. Yeah, don't really need that necessarily for your project. And of course, things change. Maybe I actually do need this at some point. I need this priority. Okay, I hope you learned something. And of course, if you have any questions, suggestions, feedback, just let me know in the comments. Also have a Discord server, so you can contact me directly. That's actually the best way to get a hold of me. And if you have any ideas for videos you want to see in the future, just let me know. Always open for suggestions. And of course, liking and subscribing this video. would really help. Well, not subscribing, subscribe to the channel, like the video, those things. Yeah. Until then, hope you enjoyed it, and goodbye.